So, question 2, you're supposed to have your book. You are given this diagram. The good thing is you can see the diagram. Alright? We are supposed to find the size of x, the size of z, the size of y. Okay? Now, if you look at x, it's part of triangle PRS or PSR. Okay? So we can use our knowledge of triangles because we are given this angle SPR at 70 degrees, we are given angle PSR. So we have got SPR as 70 and then we've got PSR as 80. So we can use our knowledge of triangles. So firstly, you must identify the triangle. Okay? You must identify the triangle. So you write in triangle PSR. Now, when you identify the triangle, okay, so we have our triangle, we have got our 80, our 70 plus x, they are all equal to 180, okay? There is a sum of angles in a triangle, okay? Sum of angles in a triangle, all right? Then you add 80 plus 70, you get 150 plus x is equal to 180, therefore x is equal to 30 degrees. Alright? So I've used grade what? Grade 8 knowledge of triangles. Yes?
So can I just ask, you have to set it out like this?
Yes. That's how
and
you
also
set it
where you get marks or haven't you got to?
Okay, this one here can be 3 marks. So let's say a mark for the statement, that is 80 plus 70 plus x plus 180. The reason, 1 mark.
And then the answer.
And the answer, 1 mark. So it can have a maximum of 3, or it can have 2 marks. If it's allocated 2 marks, it means the statement and the reason 1 mark, and the answer what? Another mark. You get 2. Now the danger is if you get this statement right. Remember the equation is called the statement in geometry. If you get the statement right but the reason wrong, you get 0. Okay? If they allocate 1 mark. But if you get the statement, to write the statement correctly, give a reason, you can be given a benefit of the doubt and be allocated a mark for the reason. So that's the first part.
So the reason is almost everything.
Yeah, it's very important. Can you hear what? Yeah. But sometimes you can also be penalized even if your reason is correct, but if your statement is wrong, you can also be penalized. Alright, so we have found what? X. Now, I now need to find Y. Now, before I carry on, I just wanted to remind you that PSRQ is a cyclic quad because those 4 points are on the circumference. The 4 vertices are on the circumference. The 4 vertices are on the circumference. So it is a cyclic quad. Now, what that means is you can use any of the 3 cyclic quad theorems, but you can't use theorem 6 because there is no exterior angle. You may not use theorem 4, okay, because we don't have angles in the same segment. So you can only use theorem 5, opposite angles of a cyclic quad. Okay? I hope you are following. Right? So whenever you are given a circle, okay, identify if there are 4 points on the circumference. If they are there, it means you are likely to need to use the cyclic quad theorems. Don't get confused. Don't get intimidated by the diagram. Okay? Then let's move on to finding y. Now to find y, we know the size of QRP, 55. We don't know z. Okay? We don't know what z is. But the good thing is, we know that PSRQ is a cyclic quad, so angle y plus angle s will add up to 180 degrees. The reason opposite angles of cyclic quad. Right? So let's move on to the next page. So that's what we have there. Right? Angle S is equal to angle Q, they add up to 180. Your reason opposite angles of cyclic quad. Remember, I gave you a document which is called the examination guidelines. By now, you should have had an opportunity to sit down and go over it. You're supposed to write in case down. Okay? You're supposed to be writing things down. You're supposed to go over. Right? Then you put your 80, you put your y. Your y is going to be 100. So that's very straightforward. Okay? Yes? What? One is doing one. I'll do that after this. Okay. So y is 100. Then we now need to get z. We now need to get z. Now to get z, can I carry on?
Yes, sir.
To get z, okay, we now know what y is. Right? Make sure you pay attention. We now know what y is, we know what x is, so we can easily find z. Now z can be found by two ways. You can identify triangle PQR so that if you add z plus y plus 55, you get 180. You're using sum of angles in a triangle. Or you can use theorem 5, opposite angles of the cyclic quad. This whole angle is equal to 70 plus z. That whole angle is equal to x plus 55. And we know what x is. Okay? So if you add 70 plus z plus x plus 55, they give you 180. You're using opposite angles of cyclic quad. Now, I decided to use sum of angles in a triangle. Okay? But it's not the only way. So if you add z, add y, add 55, get 180, sum of angles in triangle, simplify, you get your z being equal to 25 degrees. Okay? Can you see it straight? You see, your body language is very important. It shows your interest. Okay? If you don't put cyclic quad, your reason won't be correct. So you need to put cyclic there. Alright? So this angle is equal to that angle because the exterior angle of the cyclic quad is equal to an interior opposite angle. Okay? So x is equal to 120. Now that we have found x, we can find y. Y is very easy. We use theorem 3. Angle subtended by a diameter is equal to 90 degrees. So PS is the diameter, so this angle is 90. So we'll say y is equal to 90 degrees. Then we say angle in a semicircle. That's the shortcut form, angle in a semicircle. That's the acceptable reason for theorem 3 based on examination guidelines. So we now have x, we now have y. Okay? We now need to find z. Now, to find z, I can use triangle PQS. It's always easy if you can manage to get two angles inside the triangle and you're asked to find the third one. Just identify the triangle and then use sum of angles in the triangle. Okay, so here, I hope you remember this. It's grade 8 and 9. If you are given a triangle like that, A, B, C, and this is C1, that's C2, you were told that this angle is equal to the sum of A and B. So angle C2 is equal to angle A plus angle B. This theorem is called the exterior angle of a triangle theorem. You're taught from grade 8. I've taught grade 8, I've taught grade 9, so I know what's done there. Yes.
So can I just ask, can't you take, because that's a straight line, can't you take angle C and angle C2 and angle C1, that's going to equal 180?
Yeah, but why did I draw this diagram? It's correct to what you said.
Now it's just a longer method.
Yes, I'm just trying to explain that you need to remember the exterior angle of the triangle theorem. That's why I drew that. Okay? Because I'm going to use it here. This angle is an exterior angle of triangle PSQ. So 120 will be equal to Z plus 1. Okay? And this is the exterior angle of the triangle theorem. So I'll say in triangle PSQ, Okay, 120 degrees is going to be equal to y plus z. My reason, the exterior angle of a triangle. So, where there is y here, I put 90. So it will be 120 degrees is equal to 90 plus z. So, the 90 therefore z would equal to 30 degrees. Okay? I used the exterior angle of a triangle theorem. I'm sure you can see here theorem 6, theorem 3. So this is theorem 6, that's theorem 3, and then we have a grade 8 or 9 theorem on triangles. Okay? So make sure you know your theorems. Okay? Then, but let's get a question before I move on to question 1, then I'll come to another question. Uh, so we need to find x, y, and z. Now we have an exterior angle of the cyclic quad. Okay? So this 100 degrees, it's an exterior angle, and this x here is an interior opposite angle. So we can say x is equal to 100 degrees, reason exterior angle of cyclic quad. Okay? So you don't have to get confused. Once you see that, okay, this shape has got 4 vertices at the circumference. Okay? There is an exterior angle. It means this angle is going to be equal to that angle. Okay, so we now have what? X. Now, already it's indicated that this angle is 90. That's 90 degrees. So we can get y. Okay? Y we can get it. Well, these two are opposite angles. These two. So we say y, it will be y plus 90 degrees is equal to 180. Your reason, opposite angles of cyclic quad. Please, you don't have to write opposite angles of cyclic quad as supplementary with all the stuff. No. Just write the shortcut in terms of acceptable reason in the examination guidelines. So y is going to be equal to 90 degrees. Okay, then we now need to get z. Now, getting z, there are two ways. You can use this exterior angle because it's adjacent to that, or you can use this opposite angle to z. So whichever you decide, you get the same answer. So I'm going to use the adjacent angles on a straight line, so I'll say z plus 100 degrees will give me 180 degrees. My reason, angles on a straight line. Okay, so you get z equal to 180 minus 100, that's 80 degrees. And then we are done.
So we got y because c is equal to 9 and adjacent on the quadrilateral.
Well, sorry, can you come again?
How do we get y, sir?
How do you get y?
Because c is 9.
Okay, ABCD is a cyclic quad. Therefore, angle A, which is equal to y, plus this angle, they are not equal, but they add up to 180. They are supplementary. That's theorem 5. Opposite angles, the cyclic quad are supplementary.
That means that that's why we got C to be 80 because Z was, because H was 100.
Yeah, X, you got X as 100.
And
So if you add X plus Z, you get 180. Okay. All right. Any question? All right. Let's move on to another question. All right. So that's an angle in a semicircle. Also, angle AFC is also equal to 90 degrees. And the reason is the same, angle in a semicircle. Do you all see that?
Yes.
Okay? Now, once we have that, we can now carry on. Alright? Now, I want you to know that this question, it's a little bit tricky because we haven't done one of the theorems, which it's a corollary rather, which I'm going to talk about. This circle here, it indicates that BC is equal to, it indicates that BC is equal to FC. So BC is a chord, FC is a chord. Now there's a corollary or a theorem which says that angles subtended by equal chords are equal, which means that x is going to be equal to 34 degrees. Equal chords subtend equal angles. Okay, so we'll write here x is equal to 34 degrees, and then you say equal chords equal angles. Equal chords equal angles. Okay, equal chords equal angles. So if two chords are equal and it means that the angles that they subtend will be equal. We are going to talk about the corollary later on. Okay, so we have found x. We can find z or y. Okay, now to find y, this y here, all right, you need to know that inside the smaller circle, this angle, it's an exterior angle, so it's going to be equal to that. It's an exterior angle of the cyclic quad. So it's going to be equal to x plus 34 degrees. Okay? So if this angle is equal to x plus 34, and this angle, if I add it to y, I'll get 180. So I'm going to say FC, I'll call it FCD, is equal to x plus 34 degrees. And my reason, the exterior angle of cyclic quad. Okay? Which means FCD is going to be 34 plus 34 degrees, which gives you 68 degrees. Right? The objective is to get the size of angle y. So from there, now I'll say FCD plus angle y will give me 180 degrees. My reason, opposite angles of cyclic quad. Okay, I hope you are following. Anybody else got a question before I carry on?
The equal form equal angles.
This is equal, of course, okay. We haven't done the theorem yet, but I'm just telling you, because this question you cannot do it without this corollary. But I'll talk about it more later. Okay, so we haven't covered this as yet. But for this question, you needed that theorem or corollary to be able to do it. Okay, don't worry, we'll talk about the corollaries probably next week or after next week.
In 5 weeks time.
Okay, all right. So let's get on. So now that my FCD is 68, I can say y is equal to 180 degrees minus 68 degrees. And that will give you, this will give you 112 degrees. So y is an obtuse angle. Okay? Y is an obtuse angle. Now to find z, z is the easiest. Okay? To find z, it's very easy. We know that this angle is 90 and it is an exterior angle of that cyclic quad EFCD. Okay? Therefore, it is equal to that angle. Was an exterior angle of the cyclic quad is equal to an interior opposite angle. So I can say AFC is equal to Z, and they are both equal to 90 degrees. And the reason, exterior angle of cyclic quad. Okay? So Z is going to be equal to 90 degrees. Okay? And then you are done. So we found X, we found Y, we now found Z.